All right, we're about to go live here. Okay, and we're live. Take it away, Teamer.
We're live. All right. Well, hello, everyone, and welcome to the monthly audio programmer meetup. Thank you so much for tuning in.
All right, we're about to go live.
Thank you especially for the, hang on, let me mute this. Okay, sorry for that. Thank you very much also for the people who are coming back every month to thank you so much for following this. My name is Timo Dumler. I'm your host together with Joshua Hodge, who's also here. Hi, Josh.
Hey, how's it going? Great to be here.
Yeah, it's really awesome to be here. And it's actually the 12th time that we're doing this. So we are approaching our 1-year anniversary really fast, which is going to be next month in March, because we started all of this in March 2020. And as you know, this is every second Tuesday of the month at 6:30 UK time. We're delighted to have you here tonight. We have again today 2 awesome speakers for you. Today we have not really themed evening, but I would say like one common theme. I know that a lot of people who are tuning in are programming with Juice. So today we actually have both of our speakers are kind of programming like outside of this ecosystem. So we're going to be looking at like different things that people are doing kind of outside of the Juice universe, which I hope is going to be very interesting and insightful for all of you. Really looking forward to that. I guess, Josh, do you have anything to add to that?
Yeah, thank you very much. And as Teamer mentioned, we have 2 great guests today. We have Mark Heath, who is from Nice Systems, and we have Chris Santoro from SoundToys, who's joining us today. And we just wanted to take a moment, as always, to thank our sponsors who help support the Audio Programmer Meetup and make it possible. So we have Juice, the Juice Framework, we have Focusrite, and we have Sonnox. So thank you very much to those 3 for helping to support us. Also, we're always looking for other people to speak at the meetups, and we'd love to hear your ideas. And if you have something nice that you'd like to present, you don't have to be a 20-year veteran in order to present at the meetup. And you can submit a proposal at theaudioprogrammer.com/submit. Also, we have a thriving audio programmer community on Discord. So we've just broke 5,000 members on our Discord. You can come join us. It's audio programmers of all different levels. So even if you're just curious about code and what it's about, come hang out with us. You can join us on theaudioprogrammer.com/community. And with that, I think that we're ready to take things away. So who's first, Teamer?
I think, as you said, it's time for our first speaker already. Let's just dive straight in. Our first speaker is Mark Heath. Mark Heath is a software architect and developer at Nice Systems. And he's actually currently specializing in Azure and .NET. And he'll talk to us about whether .NET and C# and all of the stuff from this kind of ecosystem is actually any good for audio development. And I'm pretty sure he knows what he's talking about, because he's actually made an open source library for doing exactly that stuff. So, I'm Mark. Very, very happy, honored to have you here tonight. And I'm really looking forward to listening to what you have to say. Hello and welcome.
Great. Thank you very much. I'm just going to share my screen first and check that you can see that.
And sorry, before we do that, one more thing. Can I ask one more thing?
Yeah.
For those of us who are watching us on YouTube, please ask your questions to Mark, which we are going to be answering just after the call. After the talk. But if you do so, could you please be so kind and prefix your question with the word "question" in capital letters, so that it is easier for us in the chat to kind of see where all the questions are and kind of collate them, so we can like ask Mark all of these questions at the end. Thank you very much. That's all I wanted to add.
Okay, that's great. So just double check before I begin that you can actually see my screen and hear my voice. It's always a bit weird doing these presentations virtually, but it's all good. Thumbs up from any?
Yeah, we're good. We're good.
Okay, let's get going. So first of all, just want to say what a privilege it is to be able to speak on this meetup. I've been doing bits of audio programming for many years, and a lot of that time, particularly when I first got started, I really felt like I was floundering in the dark, not knowing what I was doing. And communities like this, where people share their knowledge, is such a brilliant thing to enable new people to get into audio programming. And the other thing I was going to say at the beginning is that often when I'm doing talks on programming, my audience is people who know a lot about .NET and nothing about audio programming. But I'm guessing that the audience tonight is kind of probably going to be the other way around, if anything. So I won't assume that you know much about .NET. I'll try and make this accessible to you, and hopefully you'll find this interesting. So a little bit about who I am. I'm working as a software architect, building digital evidence management systems in the cloud. I've got details of my blog here. I create training courses for programmers at a company called Pluralsight. And the 3 of those courses I've created there are to do with audio programming on the .NET framework. But the most relevant thing that I'm going to be talking a bit about tonight is an open source library that I created. I started it almost 20 years ago for the .NET framework called NAudio. And so tonight I kind of plan to share with you some of the things that I learned along the way, some of the challenges I ran into, and hopefully you'll find the journey interesting. And so this is going to be a little bit of a story to begin with about how I even got into trying to do audio programming with the .NET framework. And so if we go right back to the last millennium, back in the late 90s, I was coding primarily in 2 languages, or 2 groups of languages. I was doing a lot of C and C++. Most things I was coding were the Windows platform. And I was also using things like Visual Basic and Python. And the reason back then we often coded in multiple languages is because they each have their different strengths and weaknesses. So I'm sure you've heard of the difference between compiled languages and interpreted languages, and that C and C++, they're compiled directly into machine code, whereas languages like Python and Visual Basic, your code is interpreted at runtime. And so very much the way that I would always think about these languages back then was that if you wanted fast code, if you're doing something real time, and obviously audio is very often a real-time application, you want to be in the compiled world. If you want to do low-level stuff, so you want to interact with the operating system and do multi-threading and talk directly to hardware devices, you kind of want to be in this compiled world as well. But of course, the downside of it is complexity. C and C++, I'm sure many of you know, give you many ways to shoot yourself in the foot. Offers you less protection than some of these other languages against silly mistakes. Whereas often people would look down a little bit maybe on the interpreted languages as they're too slow to do anything real time. You wouldn't want to try and make games or real-time audio, for example, in languages like that. But they do have some benefits. The operating system is abstracted away from you, making it much simpler. And you can do what was called RAD, Rapid Application Development. So although maybe your program was a bit slower to run, it was going to be much faster and easier to develop. And then kind of about, I don't know what year Java was introduced, but it was about that time that I discovered it, late 90s. And Java kind of offered this interesting in-between model of the 2 paradigms. Java, as I'm sure some of you will know, compiles not directly into machine code, but into bytecode, which is kind of machine code for an imaginary virtual machine. And then what happens is a virtual machine, the Java virtual machine or runtime environment, runs that on the particular system that you're on. And that means that your compiled Java bytecode is very portable. It can run on Windows, it can run on Linux. It just can run anywhere that the Java virtual machine is. And what the virtual machine is doing is what's called just-in-time compiling. So as your program is running, it's compiling that bytecode into actual native machine code for the platform you're on. And it does that very efficiently. And so you're getting much closer to the speed of compiled languages, but bringing many of the benefits from the interpreted world. It also comes with what's called a garbage collector. So it's sorting out your memory management for you. And we'll be talking more about that because that brings some interesting challenges into the world of audio programming. And like many of the interpreted languages, it comes with a whole class library, kind of standard ways of doing everything. And that was always a frustration for me in the world of C and C++, that it seemed every time I was programming in those languages, I had to learn a new way of doing threading and a new way of doing string manipulation because there were so many different libraries, whereas languages like Java gave you one standard way of dealing with these kind of things. So I was really quite excited by Java, but I didn't really imagine that it could be possibly used for anything like audio, because still in my mind, it was in the slow category of languages. But I stumbled across this project called Java Layer. And what Java Layer is, and it came with a little player as well. So you could play MP3s in real time, entirely in Java. And that thought it was going to be too slow. All of it. Here was pure Java. That was decoding MP3 and playing it. Hopefully still hearing me okay because my connection's not great.
Yeah, your bandwidth seems to be low.
The first things I did when I started doing .NET programming was so you can find I've got a fully C# MP3 decoder that's been completely rewritten actually since it was originally ported from Java Layer. But particularly, it was good for people who were developing on the Windows platform, and that's primarily where most of my development career has been, writing Windows software. And things like Java and Python weren't initially, at least, very friendly to run on Windows. They were written more with kind of a Linux platform in mind initially. And .NET brought many of the same ideas as Java. It actually gave you a choice of languages. You could use a Visual Basic style syntax. You could use a brand new language called C#, which has kind of become my main language over the years. You could even use C++, although that was a bit clunky and annoying to work with, trying to write .NET programs in C++. I tried it and I didn't really get on with it. And you could even write .NET programs in Java, although Microsoft ended up getting, I think, sued, and that got completely discontinued. So I was very excited about .NET. And one of the first things I did when I tried out the beta of .NET, kind of in the early 2000s, was search through the class library to find like what audio capabilities has .NET got. And I was very disappointed to find absolutely none. There was no audio capabilities at all in .NET. So I thought to myself, well, why don't I write an audio library which will have basically building blocks to enable you to write audio applications in .NET, because I knew from my experiences with Java that it ought to be possible to do that. And so I wanted to create wrappers for all of the Windows audio APIs, all of the ways that you could play audio and record audio on Windows and interact with sound cards. So kind of setting the volume level of your sound card or picking which inputs, that kind of thing. I also wanted to be able to read and write WAV files and MIDI files. I was doing a lot of kind of manipulation of MIDI files at the time. So I was diving into the specs of MIDI and working out how that worked. And I also wanted to be able to play MP3s, which was kind of why I ported that Java layer to C#, because back then it was the days when, I don't know if any of you remember Winamp. We were all ripping our CDs to MP3s back in those days and playing them with Winamp. So I wanted you to be able to do that kind of thing in .NET as well. And this was a very kind of ambitious project. I kind of imagined that after a while, someone else would come along and blow me out the water with a much bigger and better library, but it hasn't really happened. There's not actually been many people making audio libraries in .NET. So this project has gone on for many years. But it really was just a hobby project. I was doing it for fun. I was learning a lot along the way, getting a lot of things wrong. But about 4 years later, I got a job at NICE. And NICE is where I still am there. So obviously I liked it. It is a nice place to work. And NICE were just about to embark on a brand new development project. And what they were going to build was an incident reconstruction platform for the public safety market. And what that means is, by public safety, I mean think primarily police forces and air traffic control, but also town councils and so on. And what this product was going to do, and it's still going, it's been a very successful worldwide product for NICE, is it allows police forces and other public safety bodies to reconstruct an incident. Maybe that's something bad has happened and they want to go to court and they want to replay everything that happened. So they want to replay all the audio and all the video and fit it together in a timeline. And so we had lots of recordings of 999 calls, or 911 in the USA, lots of recordings of police radio. So all of the radio between the dispatcher and the police cars and between the police officers is all recorded. And that can all be brought in along with the video footage, things like car dash cam videos, and put into a timeline and played back together. And as I said, this was NICE's first kind of big product they were building on .NET. And I realized this was kind of the ideal use case for my open source audio library. So I volunteered, let me be the one who makes the audio playback engine for this application. And, you know, if you'd asked me back then what my dream job was, I guess my dream job would have been to be an audio programmer and to create a digital audio workstation or VSTs or something like that, because that's always been my hobby, home studio recording. And this wasn't really that, but I actually had to build a lot of the types of features that you would need to build if you were building a digital audio workstation. So this application could play audio at multiple speeds. You could go down to quarter speed and all the way up to 16 speed, because sometimes they wanted to just skim through hours of recordings. It had some basic effects that we had to do. So they needed automatic gain control to level out the volume levels of the phone calls. It had to cope with live streaming. So the audio that we were playing, we were often still downloading from the loggers and decompressing from the native codecs while we were playing it. And one of the big challenges I faced was audio and video synchronization. It's actually a really tricky problem to synchronize audio with video. Synchronizing audio with itself is not actually that hard because you mix it all together before you give it to the sound card. But with video, you've got to try and make the audio you're playing line up with the video. And a lot of these video players, particularly when you ask them to reposition, so if somebody jumps around in time, the video players are often really bad at jumping to the time that you ask them to jump to. They might jump to somewhere completely different. And it's very hard to kind of recover from that and get everything back in sync. Now, the mixing engine won't impress you very much. In terms of the bit depth, it was 32-bit. Those of you who've dealt with mixing audio in code will know that you don't want to mix audio in PCM 16-bit samples. You want to get to 32-bit floating point. So it was a 32-bit mixing engine, but the sample rate I worked at most of the time was 8 kilohertz, because most telephone and radio audio recordings are recorded at a sample rate of 8 kilohertz. And although that might sound ridiculously low to you, in the human speech, it's perfectly intelligible without a lot of the high-end frequency information. The Nyquist frequency, if some of you have heard of that, at 8 kilohertz is 4 kilohertz. So it only records any information up to 4 kilohertz, but that's perfectly fine to understand what someone is saying. I did actually eventually have to go up to 16 kilohertz because some of the radio codecs that the police started using, like G722, were 16 kilohertz. But that's about as hi-fi as it got, this application. The other thing that I had to do with this application was a bit of audio waveform drawing, and I have also open sourced some of my audio waveform libraries, because when audio goes to court, sometimes they need to redact it to bleep out people's names and addresses that can't be heard in a court case. And so we had to give them the ability to bleep things out. So we did that. Probably the most famous use of this application was, I don't know if any of you saw this film. There was a plane in America that took off and it hit a flock of gulls and it destroyed, I think, one of the engines, and the pilot made the decision, pilot Sully, he made the decision that rather than trying to get back to the airport, he was going to land the plane on the river. I'm sure some of you remember that news story. And so after that happened, they got all of the recordings of the air traffic control, and they got the black box out of the cockpit and got the audio that had been recorded from the cockpit, and they pieced it together in this .NET audio reconstruction application as part of the investigation to decide whether he'd made the right call or not. And don't want to spoil the video for you if you've not watched the movie, but he's vindicated in the end and considered a hero for making the right decision. So it's kind of cool to know that my mixing engine had been used for something like that. Now, to rewind a little bit, when I realized that my open source audio code could be potentially useful for building this application, it gave me a bit of a problem, because I'm sure those of you who have full-time jobs as programmers will know that part of your employment contract is likely to say that all of the code that you write during your paid employment doesn't belong to you, it belongs to the company that you're writing the code for. And I realized that this was going to cause a bit of a conflict if I just brought all of my audio code that I'd been writing in my spare time and dumped it into this product, and then employees at the company also worked on the product. And I know open source has taken off a lot more since the early 2000s, but a lot of companies were very suspicious of open source back then. But I realized I did need to get this official. So I got my NAudio library up on Codeplex, which is now no more. It's on GitHub now. And I gave it a license, and the license I gave it, I wanted it to be a commercially friendly license. One of the things you find with open source audio code is that it's very often GPL or LGPL. And those licenses have a stipulation in them that if you use GPL or LGPL code, you are obliged to open source the code that you, of your application that consumes that code. And for most commercial companies who consider their source code to be their intellectual property, that's an absolute no-no. So I went with a commercially friendly license that would allow them to use my code without having to open source their intellectual property. But it did mean that NAudio has never been able to bring in any GPL other open source code. I've had to find other ways of solving problems. So we might talk a bit more about that later. You just keep an eye on the time. Right. So I'm going to talk in this next section a bit about what it's like to write audio code in C#. Hopefully this will be of interest to some of you at least. And one of the first things that I needed to do with NAudio was call all of the Windows Audio APIs from C#. And the way that you do that in .NET is using a capability called pinvoke or platform invoke. And what that looks like, I've given a little example here of here's how I would call a Windows API that's called wave-in get devcaps. And all wave-in get devcaps is an API that asks Windows to tell you what are the capabilities of this recording device. And in C#, what you do is you decorate it with what's called an attribute, excuse me, a DLL import that says which DLL is this method in. So it's in the win_mm DLL. And then all you have to do is you have to match up. So usually what you're doing, you're looking at a header file, a C header file, and you're matching up the types and signature of the method in the header file and finding the corresponding C# types. And over time, you kind of learn how to map this, but it can be a real pain to do because in the world of C, they love their hash defines. And so you're often not seeing the actual underlying type. You're seeing things like L param and W param, and you have to kind of chase down all the hash defines to work out what those are. But in world of Windows, you often see what's called a D word, double-sized word, which means it's a 32-bit integer. So you know int in C#. If you see a pointer, then you should use int pointer. And I was a little bit sloppy about this initially because when I created an audio, it was in the time of 32-bit operating systems and 32-bit processors. And you could get away with muddling pointers and integers because they were both 4 bytes long. But as soon as 64-bit came along, I had to fix every place where I'd used an int instead of an int pointer. Because in the 64-bit world, D words are still 32 bits, but int pointers are now 64 bits long. So it's important you get that kind of thing right. The other thing that you might notice in here is the out keyword on the second parameter. When you pass a pointer to a C method, to a native method, this method is actually going to write into that pointer. And so the out keyword is telling .NET that it should expect the method it calls to actually write over the memory of the pointer that it's provided. And then you have to define, essentially, again, looking at the header file, you have to define your own structure in C# that maps exactly to the structure in C. And again, it's mostly a case of just matching the types up, but you often need to add attributes as well. So two of the attributes you can see here are struct layout, in which is telling .NET that the way that it lays this structure out in memory has to remain exactly in the order that I've written the code. So it's not allowed to optimize it by moving things around because I'm going to pass this structure to unmanaged code that is expecting these fields to be in this exact order. And the other thing that you need to give it clues on is how to marshal strings. Because again, if you're a C programmer, you'll know there's many ways that you can pass strings around. You can just pass a pointer, but it may be that in your structure, you've got an array of characters, and those characters might be 8-bit characters, or they might be wide characters if you're on a Unicode operating system. And so this marshal as attribute that you can see is telling the .NET framework how it needs to marshal that string. And in this case, it can cope. If you get your definitions right, it will cope with working on both 32-bit and 64-bit processors and on 8-bit character and Unicode character operating systems, although we don't really care about that anymore in Windows because Windows is Unicode everywhere now. Let's talk about the garbage collector next, because this is kind of a big deal when we're thinking about audio. The garbage collector is a really great capability of .NET. 99% of the time, or 99.9% of the time really, you don't need to worry about it. It does exactly the right thing. What the garbage collector's job is to free up memory that you're no longer using. So unlike in C, where you have to remember for every malloc, I must remember to do a free. Most of the languages like C# will do your memory management for you. But it does it by means of this algorithm called the garbage collector. And the garbage collector is very fast. It uses a very advanced algorithm called a generational mark and sweep algorithm. And I think testament to how fast this works is the fact that we've seen platforms like Unity 3D, which is a games development platform based on C#, have huge popularity, and it's being used right across the industry for making games. The same is actually true of Java. Minecraft uses Java, which is again a garbage collected language. And so clearly garbage collection isn't an absolute showstopper for the gaming industry, but it does pose some problems for audio. And the two big problems are, first of all, the way the garbage collector works is while your program is running, you can be allocating memory, and it will just keep allocating memory, that's fine. But if at some point the .NET framework decides that A, your program is using a lot of memory, and B, the system you're running on is short of memory, it can trigger a garbage collection. And when the garbage collection is triggered, your program pauses. And that means every thread in your program stops, the garbage collection happens, and then your program carries on. Now, this is normally very fast, in the order of a few milliseconds. It's very highly optimized code. However, I'm sure many of you who do home studio recording with digital audio workstations will know that it's quite common for people who do audio recording to want to work at latencies of sub 10 milliseconds, which means that every 10 milliseconds, I have to give the sound card another buffer of audio to play. And if I miss a single one, I'll hear a dropout, which will sound like a pop in the audio. And so it's a real challenge to get very low latency when you've got a garbage collector. And so generally speaking, I try and avoid low latency wherever possible to give myself that buffer of time that if the garbage collector hits, I can still provide the sound card with the next buffer of audio without missing it. The second problem, and this is a real headache, is that the garbage collector is actually allowed to move things in memory. So after it's freed memory, it can also decide to kind of defragment your memory and move all of the used memory together and all of the free memory next to each other. And that's absolutely fine for a .NET program, because .NET programs don't deal directly with memory addresses. They deal with references to objects. So it doesn't matter if it's moved in memory. But if I've given a pointer to a byte array of audio to my sound card, and then the garbage collector moves that buffer to another location in memory, I'm going to get a nasty crash. And so what are the solutions to these problems? Well, the first recommendation I have is learn to write allocation-free code. This is a good .NET performance tip, whatever kind of code you're writing. And what I mean by that is, particularly with audio, you're often filling buffer after buffer with audio and constantly giving the sound card new buffers full of audio. And instead of every time allocating a new buffer of audio, just allocate two up front, fill one with audio, give it to the sound card, and while it's playing that one, you fill the other one. And then you kind of swap them over. So you're not allocating any new memory while you're playing audio. And that means the garbage collector has got nothing to do. Now, unfortunately, if your application has got a user interface, then it's very hard to stop that from allocating memory. As the user's kind of scrolling around and clicking around on the display, memory will end up getting allocated. But generally speaking, that's a good way to reduce the impact of garbage collection. And if you are going to give native code the address of a managed object, and managed just means it's some memory that the .NET framework has allocated rather than the operating system directly, you have to pin those so that they don't move around in memory. You tell the garbage collector you're not allowed to move this object. Or probably a better solution, and I kind of wish I'd done this more with hindsight, is just instead of getting .NET to allocate the memory, just go directly to the operating system and do a malloc just like you would do in C. And then you've got native operating system memory that's not going to move around. Okay. Am I still with you? Because I just saw a message saying my internet is poor.
No, you're good. You're all
still
good.
Hear me? Good. Okay, brilliant. So I probably won't say too much about this because I don't want to bore you with lots of low-level details, but here's a couple of ways that you can pin memory in C#. And one of the interesting things is C# has got this keyword called unsafe. And the unsafe keyword is designed to scare you away and make you not want to use it. And it's very good at that. Most C# developers don't want to touch this. But if you use the unsafe keyword, what you're allowed to do is you're allowed to get pointers to managed objects. And once you've got pointers to managed objects, you can treat them just like you can treat pointers in C. You can cast, for example, in this example, I'm casting a byte array into a short array or a float array, which is really convenient. You need to be able to do that when you're working with audio, because sometimes you've got 16-bit samples, sometimes you've got 32-bit samples. And so you need to be able to easily cast between buffer types. But it also doesn't give you any of the protection that .NET would normally give you. In .NET, it's impossible in normal code to write off the end of an array. It won't let you do it. But in C, as I'm sure you know, with the pointers, you can just write anywhere you like, and you'll just get memory access violations if you do so. And so it's possible to make those same kind of errors if you write code like this. Then this slide is just a few examples of how you would use native memory in C#. So if you want the operating system to just give you memory, you do an alloc h global. Some of you Windows programmers will be familiar with that API call. And then .NET has got these Marshal structure to pointer and pointer to structure methods that can copy from managed objects into unmanaged memory and back out again. So I do that in a number of the methods in an audio. I allocate native memory, I copy into it, I call the method, and then afterwards I copy out myself. And then, of course, you're in charge of memory management, so you've got to remember to free the memory when you're done with it, or you'll get a memory leak. Now, one of the challenges or big decision points that I kept running into with NAudio is what happens when I want some DSP or codecs. So say I want MP3 decoding or OGG Vorbis, or say I want something like a fast Fourier transform or a resampler that we'll talk about in a bit. Should I find a DLL, a native DLL that does that, and just write p-invoke wrappers for it? Or should I find the source code for it and port the source code into C#? And both of those options have got some strengths. And in some cases, I ended up doing both. The advantages of interop to native code is, at least in theory, it ought to run faster. It's not actually necessarily so true anymore. It is possible, if you port algorithms from C to C# for them to run almost as fast. But at least in theory, the C code has been more heavily optimized than what you might manage to port yourself. And probably one of the biggest advantages is if I write an interop wrapper for a DLL, and then a few months later they produce version 2 of that DLL with bug fixes and new features, I can just easily take that and be up to date. Whereas if I've ported all of the C code to C#, and they've then bug fixed it, I've then got to go and read the git diffs to work out what's changed and change my port to match it. And it means that your code can end up lagging behind. Also, it helps you avoid porting bugs. Although the C and C# languages look like they're very similar, there are a number of really nasty gotchas in there when you're porting algorithms. And I've done quite a lot of porting from C to C#. And things like particularly bit manipulation, if you're doing bitwise operators or bit shifting, they can work subtly differently from how the C code works. And so it's very easy to get weird bugs introduced if you're porting from one language to another. But the big downside is portability, because .NET runs in many places. It doesn't just run on 32-bit and 64-bit Windows, but it also runs on Linux. And with things like Unity that I was talking about, you can run C# in Android devices, Nintendo Switches. You can even run it in the web browser. And so if you're relying on interop to native code, you can only use that in places where the native code is available. So in many cases, I actually found I needed to support all scenarios to also port to managed code. And one of the advantages of porting to managed code is that I can then make the API surface area more idiomatic for programmers in C#. So it can feel more like a C# library than you're accessing kind of a C library in C#. But also porting means it's completely portable. You can run in sandboxed environments. There are a number of environments C# can run where you're not allowed to call native code. So Silverlight, which is now dead, was a way of running C# in the browser. There's a new thing called Blazor, which is very similar. But there's also UWP, which was Microsoft's platform for building those Windows Store apps. I don't know if any of you have used the Windows Store, but those apps are sandboxed. They're not necessarily allowed to just call any API, and you can't just randomly call native code unless you've got permissions to break out of the sandbox. And so having a fully managed port of your algorithm is really useful. And like I said, one of the big surprises to me of NAudio was that people started using NAudio in things like Unity 3D, which is a cross-platform games library. And people were using my library, which I thought very much of as a Windows-only library, but they were using it to make games that were running on Android and running on, I say, all these Xbox and Nintendo and so on. And that meant that they could only use the bits of NAudio that were cross-platform. They couldn't use anything that called into Windows APIs or native code. So one of the examples of this, just checking me time again, we're still doing okay, was resampling. So if you like me, try and build yourself an audio library, at some point you're going to want to resample audio between two sample rates, because if you know anything about mixing audio, if you've got audio at two different sample rates, you can't just mix it directly together. You have to resample to a common sample rate. You usually resample up to the highest common sample rate and then mix the audio together. And so initially I thought, well, could I do it myself? Could I write my own resampling algorithm? You know, I did a bit of maths. How hard could it be? What you tend to find with a lot of audio DSP, as I'm sure many of the viewers of this channel will know, that it's often non-trivial to write good audio DSP algorithms yourself. For something even seemingly as simple as resampling, you need to learn about low-pass filters, and implementing a good low-pass filter is critical to getting a good resampler. So I started off by just making wrappers for native resamplers, and Windows actually comes with a whole bunch of resamplers that use various weird and wonderful APIs. There's a audio compression manager resampler, there's a DirectX media object, and a media foundation transform. And I made wrappers for all of those. So that meant that if you were on any version of Windows that had any of those, you could just, you could just use that resampler. However, it still wasn't universally available. I was playing with Silverlight at the time, and I couldn't use those in Silverlight. So I looked into, well, could I port an existing algorithm? And there are a few communities that share audio algorithms on the internet. I don't know if any of you have seen the Music DSP site. I think it's part of KVR now. There were a bunch of resampling algorithms out there, but they were almost always GPL, which meant I couldn't touch them. I couldn't just port them into NAudio because it wasn't compatible with writing commercial software. And so eventually I found the Cocos WDL resampler, which had a license. It had its own custom license that looked like it might be compatible. So I reached out to them, the folks over at Reaper, and I said, would you mind if I ported your resampler into NAudio? And they were fine with it. So I've ported that resampler into NAudio, and that means that now I've got a fully managed resampler. Now I'll probably not dwell too long on this slide. Some of you might have seen diagrams like this before, which is a way of testing how good a resampler is. You have a sine wave that goes from a low frequency to a high frequency, then you resample it, and this resampling on the right has got a little bit of aliasing just before the cutoff point, but it's generally fairly good. If you just try and write your own resampling algorithm, like I did once, without any really knowledge of what you're doing, you'll end up with something that looks like this, where you've just got horrendous aliasing. It sounds like weird and psychedelic. You can just about hear what the original signal was, but that was just, I thought I'd show you that to give you an idea that there is a big learning curve in getting into audio DSP. There's a lot of things you need to learn, and that's why I think channels like this, communities like this are so valuable, because people are sharing the knowledge. So the final thing I'm going to do in this section, before maybe we throw it open to some Q&A, I think I'm still in my time limit, is talk about some of the Windows audio APIs that I converted, because Windows has got a bunch of different audio APIs. The first one is called WinMN, and this has been around for ages. This was part of Windows back in 1991. It's the first audio API that Microsoft created for Windows, and it's still part of Windows 10 today. And the methods start with things like wave in, wave out. And it's actually a very simple API to use. One of its conveniences is that it's got built-in resampling, which I found very convenient before I made my own resampler, because it meant that if I had one audio file at 8 kilohertz and one at 16 kilohertz, I could just play them both with 2 instances of wave out and not worry about resampling myself. It has a choice of callback models. So usually with a sound card, you give it audio and then it tells you when it's finished playing it, or it tells you, if you're recording, it tells you when it's finished recording, and you need to be notified in some way and respond to that. And wave out can do that in a bunch of different ways. It can call a function directly, it can post a Windows message to the Windows message pump, or it can use events, mutexes. And I foolishly chose the wrong one initially with N-Audio, and found myself in all kinds of deadlocks, because one of the things that you run into with audio is it really matters what thread you are on when you're doing stuff. You generally speaking want to be doing all of your audio processing in a single thread and your UI in a different thread. But you can get into a real mess if you kind of mix together some code that should be doing UI stuff is running in the audio thread, or you're doing some audio in one thread and then some other audio in a completely different thread. You can get all kinds of deadlocks and problems. But eventually I worked that out, and the wave out support in N-Audio is very stable and hasn't really needed to be fixed for years. But it's quite high latency. And by high latency I mean, don't try and play audio with buffer sizes of less than about 50 milliseconds, because you will get a stuttering sound if you do that. So you're not going to use this to make a digital audio workstation, but actually for a lot of applications, 50 milliseconds is absolutely fine. If you've just got a media player, you're just playing back stuff, most people will not even notice a 50 millisecond latency. So that's absolutely fine for the vast majority of audio playback scenarios. Anyway, in 2007, Microsoft brought out Windows Vista, and it was quite a major overhaul to the whole of Windows. They were redoing lots of stuff. They were redoing security, and they were redoing drivers. And they also completely from the ground up rewrote the audio API to the Windows Audio Session API. And Vista kind of had a very bad name because lots of stuff broke then, just because so much had changed in Windows, and it took them a while to kind of restabilize. But I was very excited about Resampling, because I thought, this is it. This is the low latency super audio API that is just going to mean that N-Audio can be even faster and even better. And it was actually a real challenge. Resampling is a very large API surface area. It took me a very long time to write wrappers for all of it. I've still not done all of it. And it's also COM based. If any of you know about COM in Windows, it's a kind of a programming model that is actually quite painful to work with from .NET, and very opinionated on what thread you call from. If you create a COM object, you have to call it from the same thread that you created it on, or jump through hoops to be able to do that. But this API, Wasapi, had two modes. It had a shared mode, which is like I'm playing audio, but other applications might be playing audio, and exclusive mode, which is like I want kind of low-level access. I want my audio to go with the minimum possible steps directly to the sound card. And like I said, I hoped this would be super low latency. My opinions of Wasapi is that you can sometimes get really low latency, but it still can be a challenge to do so. But this API was IEEE floating point right from the ground up. You always provide audio as floating point samples to it. And you have to operate at whatever the sample rate the sound card is using. And this was another thing that forced me to have a good resampler in N-Audio, because it won't resample for you. If you're in shared mode and the sound card happens to be going at 48 kilohertz and you want to play an MP3, which is 44.1 kilohertz, you have to do the resampling yourself before you give the audio to Wasapi. That can actually make it painful to work with. But one really cool thing is that it had loopback capture, which means that you can record the system output of your sound cards, which was always hard to do before Windows Vista. And so that's a really great capability. You can't still in Windows record the output just of a single application without kind of using custom third-party drivers to kind of make fake sound cards. But you can record the whole system output. And it also had some other quirks that made it hard to work with compared to WinMM, that the amount of audio that you provided, each buffer, could be different. It wasn't always necessarily a fixed amount, which made it tricky to work with. Then in 2016, as part of the Universal Windows platform, which was this new API Microsoft were creating to build Windows Store applications, they introduced the audio graph. And I was very excited about this at first because it's a really nicely designed API. It's based on the concept of nodes. So you kind of connect things together.
Uh-oh, not sure what happened there. Hopefully it'll come back in a second.
Okay, yes. Let's hope so. I mean, the worst case is his internet is cut out.
Yeah, that was pretty sudden.
Yep. Well, do we have a means of reaching him somehow and letting him know? Because otherwise he's just going to keep talking.
Yeah, I'll email him.
All right, now he's dropped off the Zoom call.
Yeah.
This actually, in 1 year of doing these, it has never happened to us before, has it? That's the first time.
Yeah, this is the first. Yeah, this is the first time. And but wow, what a fascinating talk! I never. Yeah, I don't think we've ever had a talk like that. I think the closest thing we've had was the Linux Audio API talk from Fabian.
Yeah, I think the thing that we need now is to have like a core audio one about like macOS and iOS, and then we have covered everything, you know.
Yeah. Would that be you giving that talk then?
I'm not sure I'm up to date with the latest stuff, but let's think about that.
Yeah, great to see you, Mark. Yeah, we saw you.
Apologies, for disappearing.
Oh, that's all right.
That's
yeah,
all right.
You want to continue on? Fascinating talk here.
Yeah, really, really enjoying this. I think you cut out when you were explaining that Wasapi. What was it? Yeah,
audio graph.
The loopback capture. You were saying that you can capture the like the whole system output. I don't think you. I think you didn't mention the variable buffer sizes. You were already gone at that point.
Okay, I'm sorry. I talked for another couple of minutes then without realizing I was gone. Okay, so what I basically had said was that Wasapi, unlike WinMM, when you provide audio to the sound card, it's not always exactly the same buffer size you're providing each time. And that was a bit irritating to work around. So I had to kind of rejig some of my code to cope with that. Then the next audio API, Audio Graph, that came along in 2016 was for the Universal Windows platform, which is basically Microsoft's way of enabling you to make Windows Store applications. And I was very excited about this one because it was a really nicely designed audio API. It was based around the concept of an audio graph. So, you know, if you've got a guitar, you plug your guitar into a effects pedal and then your effects pedal into an amp, you know, you connect things together like that. This API was designed that way, and I think it's a really good way of designing an audio API to connect inputs to effects to submixers and so on. And it's based on top of Wasapi. And the other nice thing about it is that it was already exposed as a .NET API. You could call it directly in C# without me needing to do any wrapping of it. However, I did play with this quite a lot. I made a training course on Pluralsight all about Audio Graph. It does have a few weaknesses and limitations, and so I feel like it's got potential for .NET programmers interested in audio, but it's not quite ready yet. It's missing a few bits that I would like. And then the final one, I'm sure you've all heard of this if you do any audio on Windows, is ASIO, I call it. I don't know how you're supposed to pronounce it. This was created by Steinberg way back in 1997. And to this day, I would say it's still the de facto standard for applications that need low latency audio to interact with the sound cards in Windows. Most sound card, I don't know why, but most sound card drivers just seem to be much better with ASIO than they are even with Wasapi, which is kind of Microsoft's theoretical best API for you to use. And you can often get very low latency. Now, one of the great things about N-Audio being open source was that I got, every now and then I'd get really great contributions from the community. And a guy called Alexander Mutel, a brilliant guy who's made a lot of really cool open source projects himself, contributed a set of p-invoke wrappers for ASIO, for N-Audio. So you can, in N-Audio, you can interact through the ASIO interface with your sound card and get the lowest possible latency I you could get with the .NET framework, obviously bearing in mind what I said earlier about garbage collection. And I think it's got a really nice, elegant API, actually. It's based on a buffer swap that works with both recording and playback at the same time. Unlike most of the Windows APIs that treat recording and playback devices as completely separate. With ASIO, you get called back to be told that the sound card has finished playing a buffer and finished recording a buffer. And that means that it's much easier to know how to synchronize what you played with what you recorded. This is a very fixed timeline. So it's a nice API. It does have some weaknesses, particularly if you want to use multiple sound cards. It's not really got a good solution for that. But it's still probably the thing you want to use if you want ultra low latency audio. I'm going to skip past these slides a little bit and just mention, because I'd like us to have some time for questions. I don't know if any questions are appearing on the chat.
Yeah, there are quite a few, but like also you don't have to rush. I think if you can take a few more minutes. I think if there's like material that you think is
okay. So I'll just show you a couple of bits of the design of the API of N-Audio then. And N-Audio, I tried to have a stream-based API. So the idea was that you created components that were streams of audio and you connected them together, and just uses a very simple design pattern called the decorator pattern, if any of you know about software design patterns. all of the classes you create implement this iWave provider interface. And all a wave provider interface has is a wave format. So it tells you what format the audio you're receiving is in, and then a way of reading audio out. And the idiomatic way of reading from a stream in .NET is that you have a read method with a byte array buffer, and you ask it to read into your byte array. You tell it what offset to write to. That's because you don't have pointers, or you don't tend to use pointers, so you have to tell it what offset in the byte array and how many bytes you want it to fill, and then it tells you how many bytes it wrote. Now that's great, but actually, most of the time, your audio might start as PCM or a codec like MuLaw or A-Law, but pretty soon you convert it to floating point. And so it's much more easy if you want to write effects in .NET. You don't want to be given a byte array, because you can't cast a byte array to a float array. So I had another interface called a sample provider that was a convenience interface that gave you the audio already as floating point samples, and much easier to write effects and so on and mixing code like that. Now the casting problem, like I said, was a real headache for me, because if you declare a byte array, I don't know if you can see my mouse pointer on the screen here, but if you declare a byte array and it's actually full of floating point samples, you can't do this. You'll get a compile error just trying to cast it to a float array. And so there's a whole bunch of different things that you could do to try and get from a byte array to a floating point array. But another really cool hack, and this is one of my favorite C# hacks that works amazingly well. It feels like it's a bit dirty, but somebody came up with this idea that you could use a structure with, and this is a special construct that C# provides for interop when you're dealing with unions. So in C code, if any of you've done C programming, you'll know that often structs are unions, that it might be this or it might be that, and they both potentially take up the same memory space in the structure. And we essentially did that with a byte array. So you say there's a byte array, but exactly the same location in the structure, there's a float array. And what that means is you can write bytes into the byte array and then read floats out of the float array and vice versa. And so that was a super good improvement to an audio, because it meant I didn't have to copy all the time or use other slower constructs. It meant I had fast casting. However, .NET has moved on since then, and quite recently, I say quite recently, about a couple of years ago, they introduced this thing called the span of T. And this is kind of what I'd wished for all along in .NET, is that with a span of T, it's kind of like a pointer, a safe way of doing pointers. A span of T can be a span of bytes or a span of floats. And what it basically means is it can point to either managed memory, so memory allocated by .NET, or to native unmanaged memory, so memory that you've got with a halloc. And a span has got a length, so it knows how much memory there is, so it's safe. It can't write over the end of the pointer. And it also can be sliced, which just basically means you can do pointer arithmetic, but in a safe way. I can pass around a span that just points to half of another span. And most importantly, it supports casting. So if I've got a span of bytes, I don't need to care whether it's native or managed memory, and I can just cast it directly into a span of floats. And then I can do my DSP, but then I can cast it back into a span of bytes, because that's what my sound card is expecting, a byte pointer. Just makes life a lot easier. And I've actually prototyped converting the whole of NAudio to use span of T. It's in a branch in the GitHub repo, but I haven't made it the public API. And the reason for that is everyone would have to rewrite their code to use span of T instead of byte arrays or float arrays. And that's a big breaking change. And I tend to avoid breaking changes, but maybe I can find a way in the future of bringing the benefits in for the people who want it without forcing it on everybody else. couple of other innovations that are happening in the .NET world. You may have heard of .NET Core. So when the .NET framework originally came out, it was just for Windows. It was very much a Windows thing. And that other people made Linux implementations. So if you've heard of Mono, that was a Linux implementation of .NET. However, .NET Core is cross-platform. And you can now run C# applications on Linux. And it has been much more highly performance tuned. So there are huge performance gains. If you're using the classic .NET framework, moving to .NET Core, things are going a lot faster. It's actually a very competitive platform in terms of its performance now. It's still got a garbage collector, so the things I said about garbage collector are still true. But it's high performance, and it's been picking up other features that are relevant if you're doing audio programming. In particular, function pointers are something that I wanted for a long time, because to call COM-based APIs, there are certain opcodes for the virtual machine that were not possible to generate directly with the C# compiler. And it meant that a lot of people who did audio programming in .NET would kind of have to do rewriting of the compiled code to change the underlying opcodes of the intermediate language. It's called CIL, Common Intermediate Language, that C# compiles into. So this will just make things like that less painful to work with. And there's another project that is, I believe Microsoft are actually going to do a Twitch stream quite soon to announce this. But you can find it here on GitHub. There's actually a series of GitHub projects where they're trying to make it so that they auto-generate wrappers for .NET to be able to call any Windows API. So all of that manual work that I did to write wrappers for hundreds of Windows APIs, this is kind of promising, if it goes well, this project, to do that automatically. And they're not just doing it for .NET. I think they want to do it for languages like Rust and Go as well. So if you're using any of these languages and you want to call any Windows API, rather than having to write all the signatures yourself and go through the pain of working out how to do it, this project is hoping to simplify that. Again, it's something that, had it been around at the start of NAudio, would have been absolutely ideal for me, but it's kind of a bit late now, but maybe I can use it in the future. So final slide before I jump to some questions. Can I use .NET for audio? Absolutely yes. I've shown you tonight the NAudio toolkit that I made. I talked to you about making a managed MP3 decoder. Again, it's on GitHub called NLayer. Another project that I did that I haven't talked about because it doesn't work anymore, Skype has unfortunately changed its API, but I made a real-time voice changer application for Skype, and that could turn your voice into a robot voice and like do funny effects on your voice while you were talking by intercepting the audio from your microphone and modifying it in .NET. And that was actually a super popular program. I had millions of downloads of that. I've made MIDI file drum remappers. A number of the people who sell MIDI drum grooves use my libraries to turn the MIDI drum grooves into the formats of all the different drum samplers that there are. And I've also shown you that for commercial enterprise applications, it's not a music application, but many companies are using .NET to build audio applications for telephony and even medical care. I know NAudio is being used in a number of healthcare scenarios as well, which is really interesting. And the final thing I'm going to say is a little bit sad in a way, but in the last 5 years, my day job has moved from working with applications that run on the client of Windows to applications that are web browser based. And that means that I don't actually need C# code that can play audio anymore, because all my audio playback is happening in the web browser. And so what that's meant for NAudio is that it's not really moving on very fast. I'm not working on it nearly as much as I used to. And so I'm on the lookout for new maintainers. So if you're passionate about audio programming and you love the .NET framework and you'd like to get involved either as a contributor or even a maintainer of the project, then feel free to reach out to me. It'd be great to hear from you. So I've just got a few links there to to myself and the projects and the audio training courses for .NET programming. But I think now's probably a good time to do any questions.
Yeah, thank you so much, Mark, for this talk. Really, really fascinating stuff. It's really interesting, like, take on making music. I'm sorry, making audio software. And yeah, I definitely a lot of new information there. I had no idea, that you could really do this stuff with C# and .NET and in this depth as well. And like, that's really quite fascinating. So thank you so much for sharing all of this. We do have quite a few questions from the audience. Let's maybe start at the top. So Steve Dwyer is asking, which open source license model did you eventually use?
So initially, I used a license called MSPL. And Microsoft, as they want to do, they like to make their own version of everything. And they made their own open source licenses. And the MSPL was the Microsoft permissive license. However, I realized that most people didn't know what that meant in the open source world because it's a bit of an unusual one. So I've actually switched fairly recently to MIT because that's very well known and it's more or less the same kind of philosophy. It's commercially friendly license.
Yeah, MIT I think is pretty popular. Thanks. So we have another question from the Monty Music channel. Did you have to ever wrap old C and C++ code for your library for low-level access? And I guess what they mean is not wrapping like C++ APIs, because obviously that's what you've been talking about quite a lot, but probably just some of your own code, I guess, or like kind of like code snippets that are flying around. I guess that's my interpretation of the question. Please let me know on the YouTube channel if that's incorrect.
Yes, so I mean, what I was talking about in the session was the two main ways. If you've got C code, you either port it, convert it directly, or you call into it. I guess they might be asking about managed C++, which I said earlier on, you still can. They changed the name of it to CLI/C something or other. You still can write .NET applications in C, and therefore, if you had some C code and you wanted to use it in .NET, you can combine the two worlds. But I found it just very complicated to work with and not particularly straightforward, because you're still having to think about how do I go between these two worlds of managed and unmanaged. So I generally prefer, if I've got some C code, compile it to a DLL if I'm running on a platform where I can do that. So one example was, have any of you heard of the SoundTouch library, which is it's a library that lets you do pitch shifting and also vary speed playback. And I thought, I don't really want to create my own algorithm for that. So I wrote a wrap around SoundTouch for some, it's not actually part of N-Audio because this was for some commercial work I did, but it allowed me to have really good vary speed playback and pitch shifting quite easily.
All right, thanks. We have another question from Atsushi Eno asking, could you actually achieve garbage collection free audio code? Could things like CER, constrained execution region, help?
I haven't played with constrained execution region. One of the troubles with audio is that you're often playing for a long time and you're going for a long period of time. If you write allocation-free code, then in theory, the garbage collector will have nothing to do. And I think, if I understand correctly, with constrained regions, you're kind of instructing .NET, please don't do a garbage collection during this period. One of the problems I kept running into with Windows Forms, which is kind of a way of writing Windows desktop applications, is that with Windows Forms, whenever you minimize the window, that's when the .NET framework thought, oh, now would be a good time to do a garbage collect because you've minimized the window. Clearly, you don't care about performance at this moment. And so it would often do a garbage collection when you minimized. But that was really annoying for people who were playing audio because they were still listening to the audio and then all of a sudden a little stutter. And I never really got a good solution to that. .NET just did it, and it was very hard to persuade it not to. But maybe the constrained execution regions would help with that kind of thing.
All right, thanks. We have a few more questions. So Ali Somai asks, is there a possibility to explicitly instruct garbage collector to ignore certain addresses or ranges? I think that's kind of exactly the thing that the last question was saying with these constrained regions.
Kind of. The way to do it, sorry, the way to do it is to just not use .NET to allocate the memory. Ask the operating system for some memory, and the .NET garbage collector won't know about it, won't touch it. So that's generally what I would do for that scenario.
All right, thanks. So then there's, coming back to the licensing question in the beginning. So Ivan S has, I guess, a bit of a similar question. And they're asking, what are the licensing considerations and moral considerations if someone wanted to port algorithms or steal code from the N-Audio repository?
Well, because it's a commercially friendly license, you can take all of the code from N-Audio, you can put it into a closed source product, and you can sell that product, and it's fine. You're allowed to do that. So I don't stop you doing it. That's kind of one of the natures of open source code. Sometimes people have tried to contribute things to N-Audio that aren't compatible with its license, and I've had to say no, sorry, that can't come in. There have been other open source projects that have just kind of lifted and shifted large chunks of N-Audio into their own projects. I feel like it'd be polite for them to say thanks if they do that. Sometimes they do, sometimes they don't. But yeah, that's the nature of a permissive license. You're permitting people to do what they want, and if they want to make money from it, they can.
So actually, you said you're using the MIT license now, which, if I remember correctly, actually requires someone who uses that in a closed source project to at least include the copyright notice and that license in their product to kind of acknowledge that they have used that software. So
yeah,
it's not,
that's all they have to do. Yeah. So
it's not just polite, but it's actually a license requirement. But they don't really have to do anything beyond that, do they?
Yeah.
All right. So Eugene Yakshin asking, can you speak a bit more about the exclusive mode versus the shared one? I guess they mean like Wasapi exclusive mode and shared mode. What happens under the hood is the question.
Okay, so the difference between exclusive and shared. First of all, if you do exclusive mode, you get to pick the sample rate. If you do shared mode, you have to work with the sample rate that the sound card is currently at, which will either, in Windows, it will almost always be either 44.1 or 48 kilohertz, depending on whether the last thing you did was watched a movie or played an MP3. In exclusive mode, it also bypasses, I believe that in the kind of internal pipelines of Wasapi, there are certain audio effects that it can run. It can do enhancements on your audio. And if you choose exclusive mode, you're asking to bypass some of that, so it should be faster. There are some other flags that you can pass to Wasapi to ask for even lower latency, which are the flags that I believe that Digital Audio Workstation authors will try and set to get the, I want the lowest level possible. But one thing they did do with Wasapi was they moved into user mode. So it's not the code, the mixing engine is in user mode, not kernel mode. It means that a bug in your audio pipeline can't take down the whole of Windows. If you remember back in the day, you could crash the whole of Windows much more easily with audio applications. It's harder to do that now. It's less common for that to happen, but there is potentially a slight performance overhead because of that. So I've never achieved with Wasapi latencies as low as I can get with ASIO. ASIO seems to be on almost always all cases. I don't know whether your experiences have been any different from mine, but Wasapi is fairly low latency, but not the most low latency.
All right, thank you. A couple more questions. Ivan S is asking, what is the theoretical maximum volume in an audio when using float? Is it 1?
Yes, so a typical way of representing audio in floating point is when you convert it from PCM. So a PCM sample goes from plus 32,000 to minus 32,000. You convert that into the range +1 to -1. And I'm sure almost all of you who've done audio programming will know that's kind of a convention.
Yep.
And what that means is you can mix other audio streams in and the volume level can go above 1. It doesn't matter in your mixing engine. But then at the point that you give the audio to the sound card is not actually operating in floating point. The digital audio converters, DACs in your sound card, are not accepting floating point. They're accepting integer samples. And with low-level drivers like ASIO, you've converted back. You've converted back to either 16-bit or 24-bit before you've given the audio to the sound card. And so at that point, you need to get back into the range ±1. So either you just reduce the volume with a multiplier, or you'd use a limiter effect to say, I'm going to clip anything that's gone above ±1 before I go down to 16 or 24-bit to give it to the sound card.
Yeah, thanks. That makes a lot of sense. There was a comment by Atsushi Eno on the YouTube chat, which wasn't strictly a question, but I'm just going to go ahead and turn it into a question because I like the comment. So they're saying, if you convert shout, float, and byte arrays, like be careful with endianness. That might bite on some ARM processors. And I guess I'm going to just turn it into a question and ask, like, with some of the byte manipulation stuff that you showed, like, should you be aware of endianness? And is that a problem when you run on like different kinds of devices?
Yeah, absolutely. Endianness matters. Fortunately, on Windows, you're almost always in little endian. And the times you have to worry about it is AIFF files use big endian. Some ASIO drivers, so ASIO has a whole long list of supported bit formats. It can be 16-bit, 20-bit, 24-bit, 24-bit pushed to this end of the 32-bit word or that end of the 32-bit word. And some of them are opposite endian. However, I haven't supported that in an audio because I haven't encountered a sound card that's needed it. So there are a few places. The other thing that I can think of is the Universal Windows platform does run on Raspberry Pi. And I actually got N-Audio and some audio code running on the Raspberry Pi. And again, your endianness is the other way around on that, although I was using the audio graph API for that, so I didn't have to do the byte swapping myself. So the answer is you rarely have to worry about it, but there are a few edge cases where you do need to think about it.
All right, great. And then actually the last question here, as far as I can see, is going a little bit outside of the scope of your talk, I guess. So it's a question again from Monty Music Channel, whether there is a good source for the binary layout of a MIDI file.
For the layout of a MIDI file, I can't remember what the website was because it was many years ago I did it, but there's very good documentation. You can read the full MIDI specs and find them on the internet. It's amazing how long the MIDI protocol has lasted. Basically, it's been more or less unchanged since the 1980s, although MIDI 2 is literally just upon us with more capabilities. So I haven't looked into MIDI 2, but if you just search for the MIDI file format, you'll find all of the kind of MIDI. There's a lot of bit manipulation you need to do with MIDI. It's a little bit of a fiddly format to work with. And you also need to learn various quirks, like with MIDI, even though there's a note off command, it's more common to find a note on command with a velocity of 0 than it is to find an actual note off command. But it's a fairly simple file format to work with, unless you want to get into sysx's. And of course, when you do with sysx's, then every synthesizer has got its own quirky sub format. I've been trying to learn. I've got a Yamaha Modi X here, and I've been trying to learn the sysx format of that because I want to do some of my own controlling of it using web MIDI. So that's what I'm doing for fun in my spare time. But yeah, just search for MIDI file format and you'll find good documentation that gives you all you need to know for all of the standard MIDI commands.
Yeah, because I do remember like the MIDI spec with all the different MIDI messages from back, I don't know which year it was, when I was actually working in Juice team and implementing the MPE spec there.
Right.
But I have never dealt with like MIDI files. I guess this is maybe what they meant. Like,
yeah, the MIDI file is pretty much the same. It's just I think there is a header. Oh yeah, so it's all coming back to me now. There's type 1 and type 0 MIDI files. And
yeah, exactly.
You have to know the headers of the both of them.
I heard this somewhere 10 years ago. Yeah.
Yeah. But I've done if you're a .NET programmer, I've done all of that hard work for you, and you can convert between type 1 and type 0 and so on.
All right. Well, thank you so much. I guess that concludes our Q&A. Thank you so much for patiently answering all the questions that the people on the stream were asking. And yeah, thank you again for this amazing talk. I definitely learned a lot, and I'm sure everyone else did as well. So yeah, thanks again. And
thanks very much. It's been a real pleasure to be with you, and looking forward to the rest of the evening.
Yeah, me too. And with that, I'm going to pass over to Josh, who's going to tell us what's going to happen next.
Yes, thank you very much, Timur, and thank you very much, Mark, for your talk. Very enlightening. We've been doing the rounds of low-level APIs. We had somebody give a Linux API talk a couple months ago, and now you've done Windows. Now we just need core audio. So if you're a core audio expert and you're out there and you'd like to give a talk and take us on a whistle-stop tour of core audio, please drop us a line. Or if you want to give a talk of any type, please get in touch with us on theaudioprogrammer.com/submit. And if nobody else gives a core audio talk, then we might have to twist Timur's arm into giving one for us. So yes, great. So we're going to move on to the next talk with Chris Santoro. And Chris is the engineering lead at Sound Toys in Burlington, Vermont, and he's been developing audio effects plugins for over a decade. He holds a bachelor's degree in computer engineering from the University of Florida and a master's degree in music engineering from the University of Miami. And yes, thank you very much for joining us, Chris. It's great to see you. And yes, we hope you're having a good time in sunny Vermont. Yeah.
Yeah, we've had a couple sunny days here recently, but yeah, it's the average temperature's been about 20 Fahrenheit, and so it's that time in the winter. So yeah.
Yeah. So it's there's so much that we could talk about. And I guess maybe one place where we could start is kind of the beginning. What got you into audio software development and curious about wanting to develop audio plugins?
Well, I think my story is not too different from probably most people's story. Most people start out getting interested in music, right? And in like elementary school, we would do like group reading in class. And I really hated having to listen to people read aloud. Like I really didn't like it. And so one way you could get out of that was to go do violin at that time. So I said, oh, that sounds cool. So I learned to play violin in elementary school, and then kind of loved it, and moved over to cello. And music is kind of something that stuck with me my whole life. But by the time I was in high school, I started to get interested in computers. And some of that is through, through video games, and really interested in multimedia technology and how computers and computer technology can, create these great creative experiences. And the first DAW that I used was Reason, and it blew my mind. I thought it was so cool. Using that in the late 90s, maybe around the year 2000, somewhere around there. Mm-hmm. And so by the time I went to college, I knew I kind of wanted to work with like multimedia technology, signal processing. And actually, at first, I was going to go for a degree called Digital Arts and Sciences, which is kind of like a half art degree. But then I decided I was also attracted to like knowing how things work down to the most fundamental level. So I decided to study computer hardware because that's just always been something about the way I approach things. Is like I need to know it all the way down to, you know, almost the atomic level. There can't be like any mysteries in the stack. So did computer hardware and electronics at the University of Florida, and then kind of touched a bit on signal processing there. And I had a job in a lab where I worked on radar. So a little embedded system, Texas Instruments, DSP, and we wrote algorithms that process radar signals for like defense stuff. And that was pretty neat, but defense wasn't like kind of where I wanted to be. I wanted to be in something a little bit more artistic and creative. And so for our senior design project, I did a guitar pedal like on an analog devices development board with a friend of mine who was also interested in audio, and he was from the Miami area. And he told me about the program at the University of Miami, music engineering technology. And so I decided to apply and went there, and it was great. It was it's in the music school, it's not in the engineering school, and that was something that appealed a lot to me. And so you're around musicians and music 24/7, and around people who are interested in that all the time. And so it was really great to be immersed in that. And then after Miami, I did an internship at Shure, the microphone company in Chicago. That was really great. And then the economy collapsed. And so I think had that not happened, I probably would have ended up getting hired at Shure. They wanted to bring me back as an intern again, and because they didn't have a job rec at that time. And then I heard through the grapevine from somebody who knew about Sound Toys about the opportunity there. And it sounded really cool because, you know, going back to my experiences with Reason, making plugins was always something that like would have been my kind of like my dream job. So I got hired, and I've been there since 2009. So it's been a fun ride.
That's great. And so you said that you went to the University of Miami, and we've had so many people, or I've met so many people through my travels that have that are alumni from there. We have Brett Porter, who gave a talk last year on MIDI 2 spec. Jay Coggin, who used to work at Apple. He's a amazing engineer, and there are loads of others that I can't think of off the top of my head. But you have the legendary Will Perkle, who was there. He was one of your professors there at Miami. Is that right?
Actually, that's not right. I was there during the non-Will Perkle years. So like Will was there like in the 90s, and then he went off and worked at Korg for a while. And so late 2000s, I was there. The professors there were this guy named Corey Chang, who came from Dolby Labs, really brilliant guy, and Colby Leiter, who is kind of an electroacoustic music expert, and really interesting and fun guy. He works at Magic Leap now. So then and then I was there just for a graduate degree, so it was just 2 years. And so Will kind of came back after that. And I'm good friends with Will, but I don't know him from having ever been his student. I just know him through that community.
Yeah, amazing. Yeah, it's so many people, so many great engineers have come from Miami. It's it sounds like they have something in the water there for sure.
I think what it is it's very industry connected. It's not exceedingly academic. And so everything's built around learning things that you can use to make real stuff and to, do things that are actually useful, rather than learning theoretical concepts from people who have, never worked in the industry. Like everybody there has, real world experience. I mean, and Will's a great person of that, like through his work at Korg and, a lot of other stuff that he's done.
Yeah, amazing. And big shout out to Christopher Bennett, who's a professor there as well. I'm not sure if you know Chris or not.
Oh, I know Chris very well. Yeah, we're both kind of from the same part of Florida. And I was there when he was getting his PhD. So yeah, we're good friends.
That's great. Yeah, Chris just came out with a book recently. I can't remember the title of it off the top of my head, but it's a great book. He actually gave me an advanced copy, so go out and get it. It's DSP and MATLAB. Really good book. So moving on. So your time at SoundToys, so you joined there in about 2007, you said, and you were telling us before the call that SoundToys was among one of the first plugin companies that ever really came out with audio plugins. So of course you have probably even at the time that you got there, the code base must have been over 10 years old. So can you talk a little bit about the challenges that you had to deal with working on a legacy code base? And that would have been pre-Juice as well. So another thing is that the plugins that you create there are not created in Juice. They're outside of Juice. So can you just talk about some of the challenges that you have to deal with working outside of a cross-platform framework?
Well, we actually work within a cross-platform framework, but it's one we built ourselves. So like tying back into what I was saying earlier, it's kind of a good match for me. Like SoundToys was a good fit for me because we like to understand everything top to bottom and control everything top to bottom. So all the advantages of vertical integration, right, is if you want to do some custom, stuff that might be really weird and not apply to a whole lot of people, you can do it. You're not really tied up. You're not limited or waiting on like any third party to implement that if you're using some kind of third party thing. And the disadvantage is, you have to do the work. Like you have to implement all those details yourself and all the, all the neat stuff that the Juice team takes care of for you. I think if, we've talked about it in the office, like if SoundToys was starting out today, like we'd probably use Juice. I don't know. I think it makes a lot of sense. But we've always been in the completely 100% proprietary boat. And so that's where I think we're going to stay because, once you're in that lane, it's more work than it's worth to get out of it. But yeah, so, I mean, talking about a long-lived code base, like SoundToys was one of the first plugin companies writing plugins for Pro Tools in the mid 90s. So, and those plugins ran on, you didn't really even have native plugins that ran on your computer. They ran on accelerator cards. So there was the Pro Tools TDM format, which was a fixed point Motorola DSP that only high-end pros had. So all the people buying those plugins were like people in big studios that made a lot of money, mixing records, making records usually, and not like you see today where you have so many people buying plugins and making music at home, and they might be doing it professionally or they might be doing it for fun. Yeah, I think like going back to your question, the main challenges were, a lot of our framework was tied to being able to support the Pro Tools TDM format and native code, because we only implemented VST and audio units, around 2007, I think. Before that, it was, Pro Tools was the only place you could get our plugins. And so decoupling from the limits, there were certain limitations that were kind of built into our code based on having the capability to run on hardware. Things like memory limitations and how we allocated memory. So when we have a product called Effect Rack, which is all of our plugins built into one. It's kind of a meta, like multi-effects plugin. And when we built that, it strained a lot of those, those limits, like having a maximum amount of memory that could be allocated. Because all of our memory is allocated in like basically a one memory pool, for different types of things, and that was related to this Motorola chip, and it had different types of memory that you would use for different types of things like signals or data or that kind of stuff. So that has some side effects that we have control over that. Like you get really good cache locality out of your, your data structures and all of your stuff that you're doing in DSP, rather than if you were just allocating DSP data for everything separately in every one of your algorithms, where they might be all over the, the place. But yeah, so I think, it's things like that, like having to have a dynamic, converting to a dynamic memory pool. That's, I think, basically it. Things of that nature, without going into it too much.
Yeah.
Can I ask you a question, or maybe just drill down into this a little bit more, because I'm just really curious. You know how a lot of companies like Native Instruments or Ableton or others, they actually do the same thing. They have like their own cross-platform frameworks that they have written before Juice was around, that they're kind of committed to now, and they keep maintaining. And I wonder how it is now, like 2021, working with a code base like that, like where, a lot of people are talking about like the newest C++ standard and all the like fancy new features that we have there, or a lot of people are talking about things like unit testing. We had, several talks about that at the last ADC. And I know that these and other things can be a real challenge if you're dealing with a 20-year-old code base, because I've also worked at some of these places. And so I'm really curious, like, what's the experience like for you?
What's the experience like for that with respect to people talking about like hot new stuff, like
whether, okay, let me be a bit more precise, like whether you kind of can or do like embrace these like new, like, current language standards, or like things like unit testing, or whether you kind of have to like just follow like a different strategy just because of like the code base forces you to do that.
I think it's generally pretty flexible. I mean, I think one of the things that might be like a shock to newer developers coming in is, our code is mostly C++, just like, almost everyone else. But C++ even means different things to different people depending on how old you are, right? So like ours is is basically mostly pre-C++ 11 C++, which is to say like it's mostly C with classes. And so it's very C oriented because the founder of Santoro is Ken Bogdanovich, and another longtime engineer at Santoro, Bob Belcher. Both of those guys came from Eventide in the 80s and 90s when you didn't even necessarily have C++. They might have been working just with C back then. So our code base, I would say, is very C oriented. And there's almost no standard library in it, because standard library used to be slow, and it used to be hard to debug. The tools have, since C++ 11, it seems to me like everything's gotten a lot better, and you can do a lot more with that stuff now. But kind of just because of convention, like we have avoided standard library in a lot of our code. And so we do a lot of rolling our own, for things like that.
So does that include things like, threads and strings and like, all of these like basics?
Yeah, it does include strings, not for threads. We have a little bit of the code that we've done that has involved threads and concurrency. Like we've used a little bit of threads in Unixes and things like that.
Yeah, this is a practice that I've actually heard happens in some gaming companies as well, where they feel that the standard library is actually too slow for their own use, and so they roll out their own standard library.
That's slow, and sometimes it's just not offering like the right guarantees, where like you have like the standard library being optimized for like, a certain algorithm being like, oh, log n or whatever, but what they need is like something different from that, just because of their use case. So yeah, I guess I think like big gaming studios like what is it, like EA or whatever they're called, like I think they all have like their own implementations of the standard library, which are just like a tiny little bit different, Yeah, and I think a lot of like the old like audio companies, they have something similar going on. You know, the ones that come from the like early 90s or like early 2000s. Like I think they probably all have the same thing going on if they ship like on multiple platforms, I would say.
Yeah, that's exactly right. Yeah, I think, and you're also right in that it has the most similarity, I think, to the game world, where you're running on and especially the older audio companies or the ones that have been around longer, like have more often would have run on esoteric platforms, you know, like that where you didn't really have nice native environments like you do now.
Yeah. Have you ever tried to create something with Juice? Have you ever tried Juice out just in your own free time?
It's been on my list to do. I'm not really that familiar with Juice to be honest, but it's been on my list to like take a look at it, just to kind of know, I think, what like younger engineers, they're most likely to be familiar with Juice if they're going to start their own plugin project. So to know what their expectations are coming in, like what type of environment do they think they're going to see, but yeah.
Yeah, that was going to be my next question. I imagine that having a code base like that there must be certain challenges for hiring engineers and what they would expect to see. Have you found that in your hiring when you go to look for other engineers, or do you feel that you have an infrastructure where you can kind of ease them into this code base?
We don't hire very frequently. We're been a very small company. So, we're about 14 people, and most of that is, probably customer support. And the dev team is 4 or 5 people. So, we're not, I don't think, again, it's not my company. It's, but the way my take on it is we're not trying to become like a Native Instruments or a Waves or something like that, where we have 100 people or, more. So hiring is very infrequent. So I wouldn't say that's really it's never been a problem. I think like anyone coming in, as long as they know C and C++, like you can get into it, and there's someone there with a lot of experience to guide you, to get used to that environment.
Yeah, that brings up a great point, which is about the company philosophy. So this is a company that started up in the mid 90s, and that at the moment you have 14 people in the company. And it's interesting because a lot of companies that have started then have grown into kind of behemoths, your Arturias, your Native Instruments. And can you talk a little bit about what the company philosophy or what the company outlook is? Is there a desire to stay small and kind of more of like a boutique plugin company? What is the kind of company philosophy there?
I don't know that there's necessarily like a desire to stay small, but I think the desire is like, it's definitely some things I've heard Ken, the founder, say is there's a desire to be sustainable. So if you are a company that's chasing like always growing profits, like that's not sustainable. That's also something I've heard the CEO of Ableton say, which was really nice at ADC last year. His talk was really great. I think sustainability and doing meaningful work. So not like cranking out products just because you need a new product, like cranking out something because you think it's unique and new and fun and is going to make a dent in the music industry and have an effect on how music sounds.
Yeah, that resonates a lot, definitely. Yeah, I think that's a really healthy approach, I would say.
Yeah, and I will say we've been fortunate to have been successful enough that we can take our time with things, and it can be a little frustrating sometimes, like because as a developer you want to release products, right? But the bar is really high for us, so we work on some things for a long time, and we even work on things that a fair number of things that don't go out the door because we, they just don't meet the bar for us, or they sounded like a good idea and then they, it kind of wasn't, it just didn't meet our quality level that we were looking for.
Yeah, and can you define what that is, the characteristic of what makes a SoundToys plugin? Because of course many people use them and know them for their unique concepts, unique ideas. Can you describe where that stems from?
Yeah, I think, well, that all comes from Ken. He's like the driving force behind all that. So, and that's, I think, one of the things I like most about working here is he's got an encyclopedic knowledge of effects. SoundToys also has like an incredible gear collection that I think like nobody else has. Like, I don't know if you've followed us on Instagram or seen things on the internet, but like it's the Noah's Ark of gear. So like every effects box that's like ever been invented is pretty much in the SoundToys basement. Like it's like, so anything you want to check out to get inspired is there. You can go use it for real. So I think to answer your question though, what makes SoundToys plugins unique is they are easy to use, but also deep. So it's this balance between, not throwing 1,000 knobs on the screen, but having an interface that can that encourages you to play with it and kind of expose new features where you can go very deep if you want to. But also, I think making plugins that are hard to make a bad sound with. So, that no matter what you do, you're going to get something that sounds good and interesting. So I think that's kind of that's the core thing to me, is like balance of ease of use, fun to use, but also like incredibly tweakable, like where you can go down to, and really go out there if you want to go there.
Yeah, when I was producing music, Echo Boy was probably one of my top 3 plugins, and for that reason, because when you look at the interface initially, it has just a couple knobs that you can just tweak, and then if you really want to go deep, you can go. The interface leads you deeper and deeper into different types of delays, and you can actually customize those delays. You can separate the delay of the right side and the left side. I almost felt that delay, that was the only one that I needed. I never needed another delay because it could make pretty much absolutely any sound.
Right. I think, and that is maybe the like prime example of like the SoundToys design philosophy. That's our goal, like almost with every plugin, would be to be like that, to be the one thing that you need of that type, to very thoroughly explore that, that area of effects. So, but it takes a lot of work to do that. It takes years. Like I think Echo Boy, I think took Ken like 4 years to make. So it's if you want to make stuff on that level, like you can't be cranking it out every year. You can't crank out a product every year. If you want to do products like that, you have to take your time.
Yeah. And does Ken still code, or does he really provide the vision and leave the coding to the rest of the team?
Oh, he definitely still codes. I don't think he'd be doing it if he wasn't still like helping create the stuff. So yeah, he's definitely, still very involved in the technical aspect of stuff.
Amazing. So you brought up that you have a lot of gear there at the headquarters. And one thing that I was wondering about is just around the subject of DSP algorithms themselves. Do SoundToys as a company, do you get involved in modeling analog gear, or do you simply use it for inspiration? Do you try to actively do like white box modeling, or do you just try to maybe approximate sound? What, if as much as you can tell? I know there's some secret sauce there that you probably can't tell us, but yeah.
Yeah, I think what I can say is definitely both of those things. So like the two things you said is analog modeling, like yes, we do that, and just simply using things for inspiration. We don't want to be seen as like a modeling company. Like if we did, like we could have probably done like 10 or 20 modeled EQs, like in any time we wanted, it would be, but we have restrained from doing that. And we all, anytime we do something, we want to model it to make sure we get the sound right, but then also you want to take it further and add something new, to the conversation.
Yeah. And what do you feel makes because of course, now you have some DSP algorithms that you can find on around the interwebs, and of course through books like Will Perkel's book. Eric Tarr's got a great DSP book of algorithms as well. And of course we have these kind of standard, I guess you could call them DSP algorithms for making a compressor or for making a filter. What is it that you feel, how do you get into the interesting space? How do you get out of this kind of standard? So there would be like a standard space, I guess, for making a delay or making, making a filter, I guess. How do you get outside of what the norm is? Is it just through experimentation, or what do you use to actually kind of fire those creative juices as a DSP engineer?
I think listening to stuff is first, just finding things that you love the sound of, and then drilling down into like, why does it sound that way? Like what makes this compressor or this delay or this, electroacoustic thing, like what makes it sound the way it does? And then you go about trying to recreate that sound, like however you need to. Yeah, and I think another thing about like how to get outside the box is to not maybe like don't look at that stuff. Like if there's other off-the-shelf compressor or filter designs, like maybe just try and do it without looking at that stuff, and you will naturally come up with something different if you don't let yourself be influenced by what's already there. Now, that being said, there is good reason to study what people have done before you, because they probably had good reasons, but that's just one thing, is to not, just start blazing your own path, rather than.
Yeah. And in terms of being a DSP engineer, so many people ask us all the time, what type of math would I need to study to really be an effective DSP engineer?
I think differential equations is like, maybe one of the biggest ones. Linear algebra, also very huge. But I think other than just numerical analysis, also, other than getting like out of the math realm, something I like to see in people is people who understand how computers work at a very low level. So like not just being a computer scientist that understands how code works, but understanding bytes and understanding fixed point and floating point DSP, and understanding like how a floating point number is represented, and understanding the implications of like a fixed point environment on your algorithm and on filter stability. And those things have kind of disappeared, like fixed point processing. And so, and going back to what we were talking about earlier, like with our code base, like a lot of our algorithms in filtering technology, like were, had to simultaneously run in floating and fixed point environments. So there were things about the DSP code that, were due to, fixed point. So yeah, I think in addition to math, really knowing deeply how computers work and what happens to sound when it goes into your computer, gets mangled up by the processor and comes out the other end.
Amazing. Yeah, I think I'm out of questions. Yeah.
Don't worry, we have plenty of questions from the YouTube chat.
Great. Right on time.
Uh-oh.
Should I start?
Yeah.
Okay, so we have actually 2 questions from Cameron Minuti, and I guess those questions should be prefixed with, if you can at all say anything about this, which you might not be able to. So the first question would be, how does Santoro model dynamic behavior in analog circuits? What sort of dynamic behavior is occurring in the decapitator?
Okay. So yeah, this is going to be one that I can't answer too much. But I could tell you what, decapitator is based on, a bunch of tube amplifiers. And I can tell you some of the dynamic things that happen in tubes when you drive them really hard, which is when you hit a tube, really, really hard, it actually kind of compresses the signal. The transfer function of the tube changes, as you hit it. So like you'll kind of get a dynamic distortion. The character of the distortion changes based on the past input level of the signal. And that has to do with the circuit and how the capacitors around it basically like charge up and change the bias points of the, of the tube or transistor or whatever the amplifying device is. So yeah, that's, yes, definitely dynamic behavior. I can't go into specifics of like, how we modeled it. I will say, the thing we always say is that listening is the most important thing in modeling, and rather than like what type of technique you used or what the actual DSP is. But yeah, there's, sorry, I can't go into more detail there.
Yeah, so I guess that's going to be the answer of the second question as well, which is, does Santoro use space state or WDF modeling methods?
What was the second thing? State space and what?
State space or WDF?
Oh, wave digital filters.
Oh, right. Yeah.
Yeah. No, we don't use any wave digital filter stuff. Very familiar with it. It's super interesting. Some of it's over my head even. Yeah, we don't use any of that. I've experimented with some state space stuff, not in filters, but in some other things that I've experimented with. So yeah, right. State space comes in big in if you wanted to do very like literal circuit modeling,
All right. Well, thanks for some insight there. Bonsembiante is asking, what kind of tools and knowledge gives you a degree like yours in music engineering? I guess the question is like, you said if you have like a degree in music engineering, what are the kind of tools and knowledge that you get out of it, which you then can apply to the kind of stuff that you're doing? I guess that's how I would interpret that.
Yeah, so I think signal processing for one, electronics, acoustics, psychoacoustics, which is how your brain interprets, sounds. And then that is all blended with, basic computer engineering stuff too. And that's kind of like how I would describe the music engineering degree. And then also it's very focused on the recording and music world.
All right. Thank you. We have a question from Monte Music Channel. They got the full package of your plugins, and they wonder if there is a chorus or flanger unit planned, not phase mistress, microshifter, or crystallizer.
Okay. They're asking about a flanger?
About a chorus or flanger, yes.
Yes. Yeah, I'll just say yes.
Okay.
Yeah, we have two. If you search probably way back to like the mid 2000s, I think we might have even like advertised a flanger plugin that was in the works at some point, but it's definitely something we want to come back to. And chorus also for sure is like would be in our wheelhouse. It's something we've been talking about for years.
All right. Interesting question from Bon Sembiante. How do you deal with the sound design? Are there music producers in the team? And can you, as a developer, like raise ideas about the sound aesthetic?
Yes, absolutely. So like, I think kind of touching back on some stuff Josh was asking about hiring people. I think one of the biggest things we look for are people that are, you know, passionate about music and care about the aesthetic and care about design and those sort of things. And so everyone on our team like has that perspective where they have an opinion, which is great, and then also like difficult sometimes because we don't always all agree. But yeah, I think our main sound designer is this guy named Mitch Thomas, who is really big synth head. He knows the entire history of synths. He's really talented, and he's a great preset designer. And he kind of leads like most of our, you know, preset creation. But we all chip into that, and that's also one of my favorite things about working for a small company, is that you do get to have a say in that sort of thing, and you get to have an impact on, you know, on sound quality, features, you know, all of that.
That sounds like a very good place for me, to me, for someone, you know, someone who's a developer who also cares about sound and all of these other aspects of like what it takes to make a plugin. So sounds like you got a good setup there.
Yeah, but there's a drawback too, which is you don't get to focus on one thing all the time. Like sometimes, like I fantasize about like, oh, it would be cool to work at a place maybe like Native Instruments or something where I could be a DSP engineer and just do DSP for like a couple of years, you know. But so it's a plus and a minus. Like, you know, getting to do everything means you kind of also have to do everything. You can't really like stay in one little box, you know.
That being said, like I know a company which is not Native Instruments, but another big one where they don't really have people who just do DSP. And at the same time, I know like a very small company where they have someone who is doing just DSP. So it's not just the company size. I think it's more like the team setup, the team culture, things like that. So, you know, or like the initial people who like started it and how they approach it and how it kind of grows from there. So I don't think it's necessarily the company size that kind of determines what your setup is going to be. I think it's more like, you know, the kind of the culture or like the individual people involved, or I don't know, but like that would just be my guess.
Yeah, I'd agree with that. I think that's true.
So we have one more question from Webo Talvatke, who's asking, since you worked at Shure as an intern, the microphone company, could you mention any skills that companies like that look for, say, in an undergrad electronics student?
Yeah, I think they, it's hard for me to speak for them for like what they look for. I don't know, but you know, I think they probably just generally want you to be pretty smart. And they were, so at the time that I did an internship there, they were just getting into building a DSP team for wireless mic stuff, because that was around the time that the big like wireless spectrum changeover was happening, and there was going to be a big disruption in like wireless microphone stuff. So they were looking at using DSP to kind of you know, solve some of those problems. So yeah, so I can only really speak from that perspective. Like yeah, just to know the fundamentals of DSP very well, and you know, be generally pretty smart to know a good bit about embedded systems and actual writing code for actual DSPs, because they make real physical products in the world that are going to have like a Analog Devices or a Texas Instruments DSP or something like that in them. Yeah, so.
Yeah, I could chime in a little bit on that as well, because I speak to a lot of companies about hiring and what they look for. I think what they look for more than anything is just somebody who's willing to learn new things, not afraid to get their hands dirty in terms of getting into code, learning new things, being able to take something that they don't, that the developer doesn't know about, and break it down into digestible pieces of information that and kind of working their way to a solution. And also building stuff. I can't believe how many people come across that I come across that want to be plugin developers, and companies say, well, show us something that you've created, show us something that you've made. And you say, well, I haven't created anything yet. I haven't made any plugins. I don't have any code that I can show you. They need to have something that they can see that you've created, something that shows your ideas and, you know, your way of thinking.
Yeah, I was just about to comment on that. It's a little bit of a chicken and egg problem with many people, isn't it?
It is a little bit, but I mean, with the tutorials that we have what, over 80 tutorials, 80, 90 tutorials now on how to start building your own plugin. And I think there's enough there to really kind of get started with something, even if it's just a delay, even if it's just a standard delay, and you've done that, and then you've created your own UI with it, just a basic UI. I think even just having that just says something about your mentality as a developer. You know, whether you like to just have everything just kind of all in the process block, or whether you like to write functions for everything. I think it just really says something about the way that you process problems and really think about them.
Yeah, and I guess also your choice of like, do you use Juice? Do you use something else? Do you use like modern C++ or not? Like, how do you structure your code and things like that, right? There's a lot of stuff to look at if you're like hiring from the other perspective, you know, from the other side of the table.
Yeah, they don't need like the Mona Lisa of plugins. You know, that's not, especially when you're talking about a junior developer. They're, you know, the bar in terms of what's expected isn't necessarily, you know, they're not going to expect something that they would expect from somebody like Chris, who's been in the business for a long time. But it's just showing that you've made something, and that you have an understanding of the basic fundamentals. And by basic fundamentals, meaning a lot of the stuff that we cover on the channel, like, you know, are you trying to call to your UI from your processor and things like that, separation of data and UI, and just basic kind of fundamentals, not allocating in your audio callback. Those are the things that they look for. And like I said, curiosity to learn more than anything, just curiosity to digest new information.
I would also, and we are kind of derailing the conversation completely, but I think it's maybe just interesting for people, because these questions come like up every single time, right? We have this meetup where like people are like, how do I get a job, or what are you looking for, and this kind of stuff. So I think probably there's also like a level of like cross-pollination if you have like other background, which is kind of not necessarily building an audio plugin, but there's some overlap with that. I think that's also like really useful, because, for example, speaking about myself, when I got my first job as a software developer at Native Instruments, which was 10 years ago now, I had certainly not written a plugin before. I was doing like astrophysics, like numerical simulations, which is something completely different, but I knew some C++, and I knew in some other contexts where you have to like churn numbers and do things like that. And I did really care about music, and I was really interested. And I think, so that was for me enough to get that job. And I think it's just, you know, for other people as well, maybe interesting that there are all other ways to get into it if you have like other, you know, relevant knowledge which kind of touches upon audio, which you can reuse maybe, and you just kind of show that passion.
Yeah.
That's also kind of a way into the industry, I would say, or at least it used to be.
Yeah, absolutely. There's definitely not a one way to go. You know, like you said, like if I saw your CV way back when, and I saw that you were an astrophysicist and you knew some C++, I would probably think this person probably can learn on the job. Like coding plugins will probably be a breeze to somebody that can do astrophysics. And
but people have all kinds of interesting backgrounds. Like one of my colleagues has a degree in history, and you know, he's an amazing developer, right?
Yeah, absolutely. And music as well. Sometimes just understanding what the user wants. I mean, I don't know. I think it would be quite difficult to be an effective plugin developer if you didn't actually produce music. I mean, I know that there are people out there that do it, but I think that there's definitely a certain experience that you get from creating music, being a musician. You have to have, I'm a strong believer that you probably have to have some sort of base knowledge or base interest even in music, how music works, music production.
Yeah, I think that's the uniting factor, right? So, Chris, you mentioned you learned the violin and then the cello, and then Mark, I see like a beautiful PRS guitar behind you. And, I also was, when I was applying for that job, I had spent like years making music and playing in bands and, playing around with Guitar Rig, which is the reason why I wanted to go to NI, right? And things like that. So I think this is maybe like a uniting force that we all just really like music and audio and sound and.
Yeah, and not to segue too far from the conversation, but another thing, another common question that we get is, well, what do I build? What do I build? And one way that, just kind of catapulting off of what Timur was saying, is that if you played the violin, for instance, you would probably have some type of intimate knowledge about how strings work, how strings resonate, about music theory. So use that experience that you have, whether it's physics or whether it's playing an instrument or whether it's producing music, and try to build something around that. Try to build something around that base knowledge that you have. And because you're going to likely know more about that particular side of things than the average person. So that would be the place to start. Like, I know more about DJing than the average person for sure. So one of the first apps that I built was a piece of DJ software. So how a person would want to use that software and so on. So that was kind of my starting point. So anyways, let's get back to Chris.
Yeah. We have 2 more questions for you, Chris.
Well, hold on, I want to make a couple comments on what you guys are just saying, just to like reinforce what Josh said about building something. I would say it's also like, don't get hung up on, like when I'm interviewing somebody or looking for somebody, I almost don't really care what like technical choices they made. I mean, I do care a little bit. If they made really bad technical choices, that's a red flag. But the fact that you chose to build something is what matters most. Like, it doesn't really matter. The details didn't really matter. The fact that you took the initiative to build something. And then also, about what to build. It's just like, well, what are you interested in? Like, what do you want? Like, and that will come through on its own. So if you say like, oh man, like when I was at Miami, I made a synth because I loved synths. And like, it was just fun. It was just what I was interested in. So I just wanted to know how it worked. I wanted to see how it would sound if I tried to make one. So.
Yeah. Great. I did have one question before we got to the last 2 questions that I forgot to ask earlier. So SoundToys is a smaller company, and of course there are a lot more plugin companies that are out releasing plugins now. What do you feel that the company has had to adjust as a whole in terms of saying, okay, well, there are a lot more competitors in this space, and now we need to pivot in a certain direction? Or do you feel that as a company, that you've established that identity and that you can say, we are who we are, and this is what we do, and we're going to continue to bear down this path? Like, for instance, have you thought about branching out to, let's say, iOS apps or anything like that, or like going in different directions, building a virtual instrument? Or has it always been, okay, we're an effects company and that's what we're going to do, and that's our bread and butter?
I think, as far as iOS apps or instruments, like, we've of course talked about doing all of those things. But in terms of like how the plugin like market has changed, over the years, and there being so many more people, like I'm not sure it's really affected much in terms of how we approach things. I don't think it really matters because I think everyone has their own unique perspective. It only matters if you don't have a unique perspective. Then it matters that there's a lot of other people around. But if you do have a unique perspective, then it sort of, it sort of doesn't matter. And I feel like, we do have our own unique take on things and our own unique approach. So.
Amazing. Teamer, got some more questions for us?
Yeah, so one is, I think you've kind of answered in your talk, but I'm just gonna, for completeness sake, repeat the question. It's from Monty Music Channel asking, did you write your own API on top of the Steinberg VST SDK, or do you use Juice, or do you write separate for all plugin formats? And I guess from what I remember, it's kind of neither of those, right? You have like your own API that you wrote before you actually put VST underneath it, right?
Yeah, so there's kind of like a platform independent format, like an abstraction of like, this is a plugin. And then you have, basically wrappers or around that for VST, AAX, and audio units, that just translate between like the different ways of like, how do you get a parameter value? How do you identify a parameter? How do you, declare what parameters are automatable and which ones aren't, where does, how does MIDI come in? How do, all those types of things, which are just like, all just slightly different between AU, VST, and AAX. And yeah, so there's kind of like a core center. And then there's just like interfaces that, interpret between, what a VST host wants to see versus what an audio units host wants to see.
Yeah, it sounds very similar to like the equivalent library at Native Instruments that at some point I was the maintainer of when I was there. And it sounds very similar to kind of what Juice is doing in the end. I think you just, if you want to do cross-platform and cross-plugin formats, I guess you just end up kind of writing something like that, which is probably going to look fairly similar everywhere at all of those companies, I would say, probably.
Exactly. Yeah. And then the same thing for, you're talking about cross-platform, like, you have some type of file API, which has different implementations for Mac and has a little interpretation for Mac and a little interpretation for Windows.
Well, actually, since C++17, we do have std file system for that. But I guess in the audio industry, not many people use that because they already had solutions like a decade before this thing was part of the standard. So
yeah, that's the trick. Like if you already have a solution, like even if the new solution is great, it's more work to move to the new solution only to get what you already had, which is working code, know.
Exactly. And it's not just more work, but also you have to retest everything. You have to without actually getting any value for the end user, right?
Exactly. Yep.
Yeah. So I think, it sounds like it makes a lot of sense what you're saying. Right. So that brings me to the last question by Kay Cranberry, who's asking, when will the big plate be released?
I can't answer that question. Again, like I'll just point back to like the high bar for things and like it'll be ready when it's ready. There's been like a lot of work put into it. I think at some companies, it might have been released already, but we do, we go to the beat of our own drum and might take things in a different direction than people expect. So, but we'll see. I don't know. I can't say how that's all going to play out. So,
well, we're going to be, I guess, watching carefully and looking forward to it if and when it happens. So, yeah. With that, we don't have any more questions on the chat unless you want to very, very quickly write something now or let me know that I forgot something, which doesn't seem to be the case.
I was interested to ask Chris whether you have to do any trade-offs of CPU usage versus your ideal algorithm, DSP algorithm that you want to write, and how do you make that trade-off?
Yeah, absolutely. And I think those trade-offs, the line where that trade-off exists has changed over time, which is a challenge, right? So if you have a product that you designed like a long time ago, like there might have been like certain considerations for CPU where you might be able to make it sound even a lot better now. Yeah, we definitely run into that. And I think even if, with computers being so fast, you have to consider that you're not the only plugin in someone's session, or they might have 20 copies of you, 20 instances, in their session. So, optimization is, there's still limitations to work with,
Yeah, great. Looks like that's all the questions that we have from the chat as well. Thank you so much, Chris, for sharing that with us.
Oh, appreciate it. No problem.
Yeah, thank you very much. That was definitely a very, very interesting session. Thank you so much for sharing, very generously sharing.
Cool. Yeah, you're welcome. It was fun.
Great. Okay, I think we'll sign off now. And once again, we'd like to give a big thanks to our sponsors, Sonics, Focusrite, and Juice for supporting the Audio Programmer Meetup. And you can join us next Tuesday. I don't have the date in front of me at the moment.
It's the 9th of March. And actually, we already have at least one speaker whom we already know. I think we're going to hopefully announce all of that soon.
Yes.
But yeah, it's going to be pretty cool, I think. So yeah, looking forward to that. Tuesday, the 9th of March at 1830 UK time.
Yes. And once again, we're always looking for more submissions. Once again, if you're getting started and you're looking to get your start and you've created something and you'd like to present it and show people like Chris what the amazing thing that you've been working on, you can submit for a presentation on the audioprogrammer.com/submit. And also, let's continue the conversation on the Audio Programmer Discord. You can come join us on the audioprogrammer.com/community. And with that, we will sign off. Thank you very much, Mark and Chris, for joining us and all that amazing information.
And thank you to everyone tuning in and asking questions and listening in and being part of this. Thank you so much. And I guess we'll see you next month.
Yes, we'll see you on March 9th.
All right. Bye, everyone.
Bye, everybody. Cool. We're off. Yes. Wow. That was